Hi everyone, welcome back to Prieto TV and welcome back to Prietology. We are starting with Season 2, and if you haven't watched Prietology, I recommend watching the entire first season, which was about chemistry up here. So, Season 2, our topic, like I said at the beginning, I think at the last episode of Season 1, is physics. We will be studying, I think, 6 to 7 episodes of physics, I think. So yeah, this season will be kind of lengthy. So, our first lesson today is called the basics of physics. So today, like we did for the basics of chemistry, we're just laying down the foundation. We're laying down the foundation before we actually get into like doing physics. Okay, so key terms, we have mass, weight, density, speed, acceleration, force, inertia, friction, and gravity. But before we do that, we have to go over something very important that's fundamental to physics. Okay, so like I said, before we begin any physics, we have to go over the system that we'll be using for measurement, the metric system. We will not be using the English system here and whatever. Metric system is used a lot for science, and also in this season we'll be using a lot of math. So metric system has to do with the SI units, so scientific measurement units like moles. I think I talked about that last season. Moles, concentration, molarity, molar mass, a bunch of other stuff, lumens, volts. So we will be using three primary measurements. We'll be using the kilogram, which is for mass and weight, for mass actually, the meter, which is for distance, and second or minute for time. Alright, so our first term is mass. Mass is the amount of matter in an object. So this has mass. This has mass. Our atom model who's back has mass. So every single thing except two things do not have mass. Mass is measured in kilos or kilograms. Kilos, kilograms, same thing. It's made with a lowercase k and then a lowercase g. Gravity has no effect on mass. So on Earth, let's say you weigh 200 kilograms, I'm just making this up, 200 kilograms, and if you go to, let's say, Mars, you will still be 200 kilograms in mass. Gravity has no effect. Like I said earlier, everything has matter. The only two things that don't have matter is pure energy and the waves that are carrying that energy, because energy is always carried in waves. Those things do not have mass. And now, one thing I'm starting in Prietology, at the end of every term, I'll just give you a little fun fact about the term. So, a fun fact about mass, the mass of the Earth is 5.976 times 10 to the 24th power kilograms, which is a lot. Alright, so our second term is weight. Weight is a force dependent on gravity. So, unlike mass, your weight actually depends on the gravity of wherever you are. This is scientifically not measured in kilograms. This is measured in a different unit called newtons. Newtons named after Isaac Newton. And then the symbol is represented with a capital N. So if you're gonna say like, oh, my weight is 3 and then a capital N, that's how you would write it. So weight can usually sometimes tell you the force that an object can exert. So like this would probably make a less amount of force than the camera that you're watching me on. It's usually very easy to measure because you just step on a scale and then there's your weight. Weight can also be used to find mass. So like if you say you are 10 times the weight of something, that means you're also 10 times the mass of something. And a fun fact about weight, your weight on the moon is 17% of that of the Earth. So your weight on Mars is 38%, and the weight on Jupiter is 213% of that on Earth. Alright, so our third term is density. Density is how tightly packed a substance or an object is. So basically how tight the atoms are together. So the more tightly packed something is, the more dense it is. And this is measured in, it's a big word, kilos per cubic meter, or lowercase kg / meters and then exponent 3 on top. So buoyancy is basically dependent on density. So things that are less dense will float, and things that are more dense will sink. That's why a piece of paper or like a paper boat would float, and a piece of like a solid piece of steel would like sink to the ground. Dense things usually pack a lot of mass into like one little tiny area, which makes them feel a lot heavier. So a fun fact about density is also a big part in black holes. Since black holes can suck up light, that means the density of a black hole is 1.8 times 10 to the power of 19 kilograms per cubic meter. So like in a meter, that's about that big. It's about 1.8 followed by 19 zeros. That's a lot. Alright, so our fourth term, this is when we actually start getting into motion, is speed. Speed is the distance traveled over time, or speed equals distance over time. That's where our math gets in. So if you travel 50 meters in 10 seconds, that means your speed is 5 meters per second. So this is measured in, like I said, meters per second, so lowercase m / lowercase s. So speed has to do with Newton's first law. So if an object is at rest, or is still going, it'll keep going, or it will stay where it is, unless opposing force blocks it or pushes it somewhere else. Friction is one of the things that can also slow speed down. Fun fact, the speed of light is 300 million meters per second. So in 1 second, light can travel 300 million meters. Alright, so our fifth term is acceleration. Acceleration is any change in speed. So if it goes like, if you're going down a highway and you swerve to the right, that's acceleration. If you're on a highway and then you go faster, that's acceleration. So any change in speed. It is measured in meters per second. So lowercase m / lowercase s squared. So acceleration is not a force. It's a result of unbalanced forces. So say you have, like going back to the highway example, you're going down the highway, then an unbalanced force makes you go forward. So yeah, basically yeah. So when acceleration overcomes inertia, which we will talk about later, you feel a force pushing on you. That is called g-force, or G for gravity. The fun fact, acceleration of a drag racer, a drag racer is 2,400 or 2,400 meters per second. So that's pretty fast. Alright, so our sixth term is force. Force is, like the equation says, force equals the mass times the acceleration. So, like, it partners with mass and acceleration to move things around. So F equals ma is Newton's second law, or if you want it in words, the force required to move an object is equal to its mass times its acceleration. This is measured in newtons, just like weight, with a capital N. So, like I said, it has to overcome inertia, which we will talk about next, to move. When a force is applied to something and it makes it move, another equal force is applied in the opposite direction, which is Newton's third law. So every action has an equal and opposite reaction. So let me just give you an example. If I push the table here, the table is going to push back with the exact same amount of force, and basically almost nothing happens. Fun fact, there are actually 4 fundamental forces. All the forces in the universe are made out of these 4. The first one is weak nuclear force and strong nuclear force. We'll talk about them later when we get into parts of atoms, more deeper into parts of atoms and radioactivity. And electromagnetism, that's another one we'll get to when we get to electricity. And gravity. Gravity is on this list. Alright, so our seventh term is inertia. Inertia is basically it's a force that makes things hard to stop. So if like a car is just rolling down a highway and there's no way to stop it, it's inertia. So this force is measured in Newton meters. So capital N-M, Newton meters. So like I said, it's an object's resistance to motion as well. So inertia usually works with an object's mass, but momentum works with an object's mass and speed. So something with like a lot of mass that's going at a very high speed has lots of momentum. So, fun fact about inertia, it's used to measure mass in 0 g. I'm not sure how they do that. Alright, so here we have the penultimate term, our 8th term, friction. Friction is a force that tries to stop motion. So like the friction of your shoes tries to stop the motion of your feet so you don't fall. This force is measured in newtons like many other forces. Friction, when friction is applied, it lowers energy, makes heat, and it usually likes to wear things out. Friction also usually works with entropy. We'll talk about entropy next class. And when friction makes heat, the energy is spread out all over the object. So like when you how's a good way, so in a car, when the wheel spins around the axle after you use the car, there's a lot of friction. So when the axle usually gets very hot, so don't touch it. Friction, fun fact about friction, a drag or the friction on a car is about 280 newtons of force. So 280 newtons of force is trying to stop a car from moving. Alright, so our last term today, gravity. Gravity is a force that occurs between the attraction of two objects. There is really no real measurement for gravity, but there is a measurement for gravitational force, and that is the force in newtons per kilogram. So capital N/lowercase kg. It's one of the 4 fundamental forces like I listed when we were talking about force. It combines with mass and distance to get stronger. So mass and distance would be variable. So if something's more massive, it has more gravitational force. If something is farther or closer, the gravitational force is stronger. The range of gravity, the range of like the pulling range, it's infinite. So like, but farther away, the pole is smaller. So like a star probably like billions of miles away has like microscopically amount of force on our planet. Fun fact, the carrier of gravity, so there's a particle called graviton. It's a carrier of gravity, but we don't know much about it because it's a hypothetical particle. Just some quantum physics for you. Alright, so I think we finished all the key terms for today, so let's move on to experiment of the day. Alright everyone, this is experiment of the day. It's called What Goes Up. So what you need is a large garbage bag. This is just one folded up. 2 plastic sandwich bags, water, some water here, and 2 raw eggs, so like still liquid inside. Okay, so basically we're gonna go outside because this usually gets pretty messy. Alright, so as you see here, we're outside. So Matt is set up on the floor just to catch any broken egg parts that may come out. So what you do, you have 2 bags, get your water, fill 1 bag with it, so that's good. So you fill 1 with water, then you take 1 egg and put it in the water bag. Alright, so we have 1 bag. Then you take another one and just place it in without water. Alright, so now we take this up. Okay, so now we have our eggs. Now we will drop them on 3, 2, 1. Alright. And as you can see, this one is just dead. This one is basically just mush. This one, however, is also kind of mush. But the thing is about this, the shell stayed almost intact. Let's go back inside to examine the results. Okay, so now the experiment is done, we examine the results. So the reason that the egg with the water stayed mostly intact and the other one basically shattered into 1,000,000 pieces is that when the eggs are dropping, they gain speed. We learned what speed is, so distance over time would be speed. So the more speed they have, the more energy. Without the water protection, the egg without the water breaks and shatters. But the egg with the water spreads out the energy and it doesn't really break that much. So it decreases the speed and also lowers the force of the impact. Looks like that's all for one lesson. So last time, I think last season, we went out of a chemistry book. Now this time we're going out of the same like series but in a physics book. And the experiments are still coming from the big book. I'll leave a link down in the description if you want to find them. Alright, so now that we're done with this lesson, our next lesson is going to be about energy. So potential energy, kinetic energy, and I think we're going to get into black body radiation, I think entropy. So that should be exciting. Well, everyone, thank you for watching, and if you like this video, leave a like and consider subscribing. See ya.